So my brother finished CS50's memory module, and he said, I can't wait to get into Python and not have to deal with memory anymore. It's like wanting to be an architect and avoiding structural integrity. Why would someone learning computer science want to avoid memory? Because CS50 teaches malloc and free, and then jumps straight into Python. Is it just CS50? Well, no. I asked my students who have finished entire CS degrees, and they said memory allocators were never covered, not in the intro and not in the advanced courses. So what are allocators and why does this matter? Because malloc and free is just syntax. It's how you interact with the default allocator. Allocators are how you actually reason about memory. That's the difference. What does this look like in code? Let's walk through two examples. The first is written the way CS50 leaves off, and the second uses a simple technique to drastically simplify memory management. Alright, so here we are. I've got a file here which includes the headers that we're going to need. We're just going to use the standard way that CS50 teaches you to allocate memory. We're going to use malloc, and we're going to build a linked list that has a set of actions inside it, which we can then play to mutate some data. So we'll just build this out real quick. So we've got an action node. This is going to be our list node. It's got some description, which is going to be some allocated string. And then it's got a delta, which is going to be the difference that this action is performing on the data. And then it's got a next pointer. And then we're going to have a state that we're going to modify, which will start at 0. We'll have the head of the list, which we'll have to allocate. And then we will set the 0 the memory here. So we're going to use, now I could use calloc as well, which would clear the memory, but I don't think they teach that in CS50, or at least I didn't see it in the notes. Now we're going to save the tail of the list, and then we're going to operate on that data in a second. But I'm going to make a function first. This is going to be the function that produces a new node and modifies and stores the data. So we're going to say we're taking a tail and some value that we're going to set to the state delta, which I guess I should call delta. And then we're going to make a new node by allocating it using malloc. We're going to return this node eventually, but first we're going to do a couple of things. We'll set the description and we'll allocate that as well. We'll say it's going to be a string that's 20 characters long, and we'll put into that string something like this, just to say what we did. So we added, or we actually I guess modified by is the correct terminology here. Now we're going to set the state delta to the delta. We're going to set the next pointer to null, so we don't have garbage data in there. Actually, we could just do the same thing that we did here, which is 0 at first. And we don't have to do that. And then we're going to set the next pointer on the tail to this action, and then we'll return it. So, the window cleaners are coming. Okay, better hurry up. So we're going to say tail equals modify by, and we're going to pass in the list, and then we're going to pass in the number 4. We're going to modify this list and add the number 4. Actually, that doesn't make sense. We should pass in the tail. So we're going to do 4, 8, 12, and then we're going to do -3, let's say. Now, pretty straightforward stuff. Now let's perform our actions. So we're going to do a simple loop as we usually would. For a linked list, we say while current is not null. We're going to set current to current next, but that'll be the last line. First, we're going to do, we're going to modify the state. So we'll add the delta, which could be a negative number, and then we'll print what changed. So we'll say current description and then the state, and that's it. So let's just do this first, and we'll run it in valgrind. So you can see we've got this state, it's modified by 4 to 4, and then modified by 12, and then 12 to 24, and then -3 to 21. So that's exactly what we would have expected, right? You can see we lost some, we leaked some memory here, which is expected because we didn't free anything yet. So let's just free it how we're taught to free it. So it's the same as this, same loop again, but we would say something like action next equals current, and then free current, and then current equals next. All right, so that's how we free our linked list. Let's run it in valgrind again, and you'll see we've got some issues here. Oh, sorry, next equals current next. And you can see we've lost 80 bytes. Now those 80 bytes are coming from this string allocation that we did. So this isn't freed. Now you might think, okay, well, you can just free that by doing something like this. Free the description, or free the current description. Either way, right? So free the description. Now we've got no memory leaks. Perfect. Okay, but the thing is, this is actually a bad sign. So you have to remember to free this description. Now what if this was some other struct, and then in this struct, you've got like another allocated thing like this, and so on and so forth. You might have multiple levels of nested allocations and all kinds of things like that, where you're going to have to traverse all those pointers, make sure you don't forget any. And then if you're doing the freeing at different times in your program, because you want to, like, you're done with the node, but you free it at some point, like before you free the other ones, well, you're going to run into a bit of a problem. And it's just remembering to do all of this. So, okay, let's take this example and we'll just make a new file, and I'll show you a simpler way to do this. You add like a few lines of code, and then the way that you think about it can totally change. Okay, so I've made this file called allocator.c, and I'm just going to put everything from the other file into here. And we're going to make a few simple things. So I'm going to make first a new kind of struct, which is going to be called an arena. Now it is an arena technically, but you might also think of it as a linear allocator. So this is actually a memory allocator. So it's going to have some data. This is where we're going to get our memory from. So we're going to make a big buffer and we're going to get it from this buffer. And then we're going to say there's some amount of data that's used and there's some capacity, which we're going to set up. That's the amount of data that's available in this arena. Now I'll make a simple allocate function here. Takes in an arena pointer and a size. Now I just want to be clear, this is just the simplest implementation. It's not really production ready or anything like that. It's just to show you the concept. For one thing, it's not aligned. Also, it takes integers instead of, large numbers and all kinds of stuff. So we say if the capacity, or rather if the used plus size is less than or equal to capacity, then we can return some result, which is valid. So first we'll say result equals null. If we're out of memory, we're going to return null. That makes sense. And then if we have enough memory, we're going to say result equals, we're going to cast this to a character or a byte. We're going to say arena data plus arena used. That's going to be the start of our block that we're allocating. And this has to be a pointer. Then we're going to say arena used plus equals size to basically move the front of the pointer, or the front of the position, to the right place, return the result. I think that's pretty straightforward. So we're just going to move through this buffer step by step until we run out of memory. Now what does this mean for us? Well, for this function we can actually add an arena parameter here. Then instead of malloc, we can say arena alloc, pass in arena and size of exactly the same that we were going to do before. Okay, so now we've got memory, but it's coming from, this thing. What's the difference? Well, let's have a look. Just need to pass in an arena here, which we haven't made yet. So we're going to make it now. Now remember, we need some data. So we're actually going to use malloc for this. We're going to say, let's just say this arena is enough to hold 10 actions. So we should understand a little bit about our program. How many actions are we going to have? Or what's the upper limit, if there are any? Actually, I'll just make this into a little variable here called size. This into a variable. All right, and the capacity is the size, and that's it. So the used is going to be set to 0 automatically in this because of how we're initializing this struct. We pass the arena in here, but we're also going to use it here. Okay, I'm going to uncomment the free. I'm just going to make sure that this actually works as well. So I'm going to open up a new tab here. Okay, I need to also, actually I don't need to do that. I just need to build this with debug symbols, allocator.c. Run it in valgrind. Okay, so we've lost 240 bytes. That's expected because we never freed anything. Now here's the cool part. Okay, all we've done is this one line. We free the data. Let's build it. Run it again. Look at that. No memory leaks. Didn't have to do any pointer chasing. Didn't have to think about it at all. All you need to think about is my memory lives for as long as this thing, this memory allocator. So when I free this memory allocator, all of the stuff that I put into it gets freed. Now this is a very powerful technique, as you can imagine. So I'll give you an example of something that I do in my course where I teach game programming. In a game, you'll have usually some kind of loop like this while the game is running. And you have a bunch of stuff here like take input, render the scene, actually update the scene, update the state, and render the scene, and maybe do some debug stuff as well. Okay, and a lot of this stuff takes memory allocation. You need to do like allocations every single frame that the game is running. So what you can do is you can make an arena called the frame arena, or whatever you want to call it. Okay, and this thing just has a big buffer of memory, or it can grow depending on how complex you want to get with it, right? Let's just say this is like 5 megabytes or 50 megabytes or 100 megabytes, whatever, of memory. Okay, and you just push into this arena all these temporary little allocations you need to do. Like when you're doing physics, you might need to get a list of hit results, and that could be totally dynamic, right? Or if you're doing a lot of string manipulation in the frame, you might need to allocate strings to search for stuff and whatever. Anyway, so you put all of that stuff into this frame arena, and then at the end of each frame, you just clear the frame arena. And what would clear be? Well, this is actually the even cooler part. Clear would actually be something like this. So it takes an arena, and then all it does is it sets the used amount to 0. So it actually doesn't release the memory back to the operating system and then allocate it again. You just push the pointer all the way back to the beginning, or the position, and that allows you to clear the memory but not take the performance hit of actually releasing the memory back to the operating system and then allocating it again at the start or straight away or whatever. So yeah, these things are very flexible. As I said before, this is not an implementation that you would use in production, but it's just a simple demonstration of how you can think about these things a bit differently. So I think it's really important to learn this stuff. I was kind of shocked that it wasn't taught in CS50 at all. What I saw in CS50 is the lecturers, they're really fantastic. They really have great energy. They seem to teach very clearly and concisely the concepts, but it stops just short of teaching something like this, which I think would make a lot more students come away feeling a bit more secure in using manual memory managed language, rather than coming away with the feeling like pointers are scary and memory is scary and it's so much corruption. And well, that sounds a bit strange, but you know what I mean. Anyway, links in the description if you want to check out my game programming course. You have to understand a little bit about programming. Having done CS50 would probably make you knowledgeable enough to do it. It's not super advanced, it's like intermediate. So yeah, check it out in the description. We use Odin and raylib to focus more on the game systems programming rather than building fundamental data structures. So Odin already has arenas built into it, so we just use those. Yeah, if you're interested in that, check it out, and I'll see you in the next one.